Hello everyone and welcome back to Algebra 1. Today we are actually going to be continuing with what we left off last class with quadratic functions. Now, we had this example that we went over together and how we found the vertex. And the vertex we found was 3 and negative 5, okay? So 3 is our value for x and negative 5 is our value for y. Okay. Now what we're going to be doing is finding two other points in our graph to be able to graph our parabola. Okay. So let's get started. First off, our y-intercept is already given to us. Now, you know how I've told you that the formula is like this. Squared plus bx plus c. Our y-intercept is actually given to us right here. Our y-intercept happens to be whatever c is. Okay? So, knowing this, that it is whatever c is, what is c over here in our example? It's 4. Okay? And what would x have to equal in order for us to get 4? It would have to equal 0. And let me explain very quickly why. So, we will have x equals 0. And we're going to plug it in. So y is equal to 0 squared minus 6 times 0 plus 4. Y is equal, 0 times 0 is 0, and 0 times negative 6 is 0. So we are actually left with just the 4. Okay? So you see how I did that? So we have found one of our points, x equals 0, and our y-intercept is going to be 4. Okay? Let's see how we would find another point. Now what we're going to be doing now is finding our second point. What we're going to do is we're going to choose a number. And there's actually no right or wrong answer as to what number you choose, but there is a rule. It has to be on the same side of the graph as the y-intercept, meaning it is on the positive side, so you have to choose a positive number. Okay? Alright then. So we know we have to choose a positive number. I'm going to choose 1. Keep it simple, right? So we're going to have x equal 1 this time. So let's go ahead and plug it in. It would be y equals 1 squared minus 6 times 1 plus 4. 1 squared is 1 minus negative 6 times 1 is negative 6 plus 4. If I add 4 and negative 6, that will leave me with negative 2. And if I subtract 1 and negative 2, it will leave me with a negative 1. So y is going to be equal to 1, meaning that my second point is going to be 1 and negative 1. Okay? There are our two other points. Let's see how we would graph. Now let's go ahead and graph the points we got. Let's start off with our vertex. Our 3 stands for x, so we're going to move over 3 times on x. Positive, of course, so we're going this way. So 1, 2, 3. So we're going to be right here. Now we're going to be moving down 5 times down the y-axis because our point is negative 5. So That is our vertex. Let's go ahead and label it. 3 and -5. Let's graph our first point. 0 for our x-axis and 4 for our y. So 1, 2, 3, 4. And right on the line to be able to stay on the x-axis, okay? Now our second point is 1 and -1. So 1 and -1. Be right here. Okay. You see how our line is like this and it's just a line? Now we know that a parabola has an axis of symmetry, right? So what we're going to need to be doing is actually picturing what it would look like if we would fold it in half in order to get the two other points that belong in there. Like I said, we're basing ourselves off of the axis of symmetry, which I'm going to draw a line would be right here. Okay, again, a parabola is in a U shape. So if we were to fold this way, what coordinates would that give us? Hint, our y's will be exactly the same. So I forgot to label my points. So this one was 0 and 4. And this one was 1 and -1. Okay. Now, we know our y on this side is going to be -1. But what about our x? It's on this side, not on this side. So, let's see. We're right here, and we go over 1, 2. So we should do the same thing to the other side, but in the opposite direction. So 1, 2. That leaves me at 3, 4, 5 for x. So 5 and -1 would make my point be right here. Okay? Let's go with our top one. Again, our y is going to be the same, so it's going to be 4. Let's figure out what our x would be. So the same thing. From our axis of symmetry, we would move over 1, 2, 3 times in this direction. So we would move the same amount of times, but in the opposite direction from our x-axis. From our axis of symmetry. So 1, 2, 3. Leave me at 0.6. So let's go up 6 over and 4 up. Will leave my point right about here. Making our parabola look like this. Okay, very well, you guys. Now, following the same steps I took to find the 2 points of the parabola and then figuring out what the other 2 points were, I want you to do that with your assignment from last time. So you're still working with the same problem. You should have figured out the vertex. So you would know that the vertex is 2 and 2. Now that you have your point of axis of symmetry, go ahead and find your other 2 points from one side, and then using your axis of symmetry, tell me what the other 2 points would be. If you have any questions on it, please don't hesitate and ask. I'm here to help. I hope you all have a very wonderful rest of your day, and I hope to be hearing back from everyone very, very soon. Goodbye.